How's it going, everybody? In this video, we're going to be focusing on some just minor enhancements to OSPF for things like the network type and for authentication from both a CLI and a vManage template basis. And you might ask, well, why does this really even matter? Well, it's not specific to vManage or CLI or SD-WAN in general. It's more or less how would you do it through the vManage and through the CLI, just so you know how, but also just so you're aware of some of the enhancements to it, because just knowing the basics, like if you have a CCNA level of understanding with OSPF, so you know what OSPF does, you've got a basic understanding of how the neighbor discovery process works, how the link state databases are exchanged, and then how SPF runs and how to enable OSPF on a particular interface. Those are all great basic understandings. But if you want to take that a little bit to the next level, maybe start diving a little bit into your CCNP level training, that's basically what this is going to be for. So the configuration on the CLI will go pretty quick, obviously, because the commands are simple to type in. The commands or the feature template development is going to take a little bit longer to get working, simply for the fact that it's through a GUI. We have to wait for it to get pushed and those things. So what I'm going to do is I'm going to walk you guys through just the basics of the reason why we would change the network type and the reason why we would enable authentication. So let me pull up the command line and let's take a look at the switch, because the iOS data SPF database is a little easier to read. So we're going to do a show IP OSPF database, and what you're going to see in here for this section right here, right? Not this section up here. We're not looking at this, and we're not looking down here. We're looking right here, which is the net link states. This, ladies and gentlemen, are your Type 2 LSAs. What are Type 2 LSAs? Those are the designated router LSAs. So this is the, if you were to look at these outputs and see what's going on, what you're going to see are the devices that are connected on a particular link and who's in charge of controlling the routing updates. So what does the designated router do? Well, at a high level, excuse me, what it basically does is, instead of you having a scenario where you have 3, 4, 5, 6 routers connected to the same LAN segment, instead of everybody going out and trying to exchange routing information with everybody else, kind of a full mesh type of design, there's an election process or a delegation of who's going to do that, and that's called a designated router. So for those of you that like to go out and do a little bit of drinking at night, you probably heard of the designated driver. The designated driver doesn't drink, right? So they're sober to drive. Well, here, it's kind of the same, similar concept, where you have a dedicated device that is going to handle all of the routing updates for a particular LAN segment. So a router can be the designated router for multiple physical LAN segments, or it could just be one for one LAN segment. It really depends on how many physical links you have. But in this case here, switch 16, it has a higher IP address. So if we were to look at these details and look at the net link states, the network, and look at this is the designated router outputs. So let me go ahead and show this a little bit more. What you're going to get is you're going to see on the connection 10.1.16, right? So this is the connection to vEdge 1. You're going to see that we have two devices. The attached router is vEdge 1 and switch 16. For the connection to the ASA, we have the ASA and we have the switch. For the connection to the vEdge 2, we have vEdge 2 and we have the switch 16. And for the connection to router 5, we have router 5. Now what's cool about this is it tells you who the DR is. It says right here, is 10.5.16.16 is the designated router, which means switch 16 for the connection down to the router 5 connection happens to be the designated router. For the case where we're dealing with the connection to vEdge 2, vEdge 2 happens to be the designated router. Okay? We come up a little bit higher. For the connection to the ASA, who's the designated router? Switch 16 is, because his IP address is the advertising, is this guy. If we come up a little bit higher, we can see that in this case here, vEdge 1 happens to be the designated router for the connection to vEdge 1. So as you can see, when you run into situations like that, if you're going to run broadcast mode, which assumes that you're going to be connecting to more than one potential OSPF peer over the same physical connection. So if you're in the same subnet, right, 10.1.1.0/24, you could have potentially 250 OSPF adjacencies, one to every device in that VLAN. And realistically speaking, that's not going to happen, right? But the potential is there if we wanted to create it. Now, in this case here, if we did not want to deal with the Type 2 LSA, let's say, for instance, one side is a Type 2 LSA, the other side doesn't advertise Type 2 LSAs. So what happens if you don't advertise a Type 2 LSA? Well, that means that your network type is not going to be broadcast or NBMA on the Cisco router side. And as far as I know, I don't think the vEdges support non-broadcast multi-access, but non-broadcast multi-access and broadcast are the same, use the same LSAs, so Type 2 is an option. In this case here, we want to flip it over so we're not using the mode of broadcast. So we're not going to use a Type 2 LSA. We're not going to be relying on a designated router. To fix this, it's actually really, really easy. If we were to go to switch 6, and switch 16, and type in interface gig 0/0 and type in IP OSPF network type, we have a couple of options. Right now, by default, we are broadcast. That's what it is by default. We have non-broadcast, right? Non-broadcast means that you're not going to be sending this traffic over a broadcast-enabled network. So, for example, Frame Relay would be a very popular solution for that when broadcast wasn't enabled for Frame Relay networks. Non-broadcast means you're going to have to define who you're going to peer with through the neighbor statement. We're not going to get into any of that right now, but in case you were wondering, that's how that would work. Then you have point-to-point and point-to-multipoint. So there's also another one out here, point-to-multipoint, and then non-broadcast. But we're not going to talk about that either. We're going to simply create point-to-point. So this is going to eliminate the Type 2 LSA. Okay, so I'm going to go ahead and type that command in, and that's going to cause the adjacency to go down. And on some boxes, it'll bring it back up, right? So we can see that right here it says the network type mismatch, indicating a potential network type mismatch. So what's happening here essentially is the Cisco router or Cisco switch side is the connection between switch 16 and vEdge 1. On switch 16 side is the network type of point-to-point, but on the vEdge 1 side, it's still broadcast. So to fix this, we're going to go over to vEdge 1. I'm going to log in real quick. Hopefully I typed that in right. Apparently not. Admin. Again. Of course it would. Admin. There we go. So we're going to go to global config, VPN 1, router, OSPF, area 0, interface, GE 0/2, and then underneath here we're going to specify network and point-to-point, right? So we're going to hit the enter key and commit that change. Okay, so now if we go back to switch 16, we can see that it went to full. Whoops, I did not mean to do that. Let's pull up the CLI again. We can see that it went to full again. Now, in situations where you have a network type mismatch, so one type is advertising the DR LSA, the other side is not, what will end up happening is the adjacency will still come up, as you saw, and the database exchange will still happen. However, when they go to check on what's being exchanged between one device and the other, if one device is propagating DR LSAs and the other side is not, there's going to be a mismatch in the type of LSAs that have been exchanged. One side will have one side won't have what that other side has, and SPF will not run. SPF will stop at that point and go, well, we're not synced up, and this is where that network type mismatch error occurs, and you have to fix that. So be cognizant of those details when you start playing around with this stuff. Make sure that you have everything dialed in the way that it needs to if you're not going to use the broadcast mode. So I'm going to go ahead and do the same thing on interface gig 0/1. So interface gig 0/1. I'm going to go ahead and hit the up arrow and do this, and you can see that this has been affected now. So it's going to go down. They're going to go through the process. I'm not running the debugs, but if there were debugs running, you would see that the database exchange was happening, and now we go back to loading full. Now to fix this, I'm going to pull out vManage. I'm going to go ahead and log in. Get rid of this little piece right here. And then I'm going to update the template for that. So under templates, underneath feature templates, I'm going to go grab the dual site VPN template for VPN 1 right there. I'm going to edit that. And then underneath the area, I'm going to edit this for the interface. And then underneath the interface, I'm going to click on the advanced options. And then underneath here, for the network type, I'm going to change this to be device specific. And it's going to be, you could set it to global and be point to point if you wanted to. But in this case here, I'll just go ahead and do it there. So we don't have to mess with it down the road. I'm going to go ahead and save the changes, and then save the changes again, and then update. And then as soon as I do that, I'm going to go ahead and see the edit device template. We can see that since it's global, it's not going to show up here. We're going to click on next, and then click on this guy right here to see the updates. And you'll see that the propagation will work as we've described. So it'll just change the network to be point to point. Give that a couple seconds to show up. Config diff will go underneath here, and you can see that the network point to point. So we're going to go ahead and configure devices. And we'll wait just a moment for it to do its thing and push its update out. That'll be a pretty quick update because we're not updating a whole lot. I'll go ahead and pause until it's done. Okay, so the update is done. So we can see that hopefully everything is squared away now. And it went down and came back up again. And if we do show IP route, we should be receiving routes in that just came in a couple seconds ago. So we are getting the right type of stuff. So now if we do a show IP OSPF database again, you'll notice that the type 2 LSA, so remember the summary? Let's scroll up here a little bit. You'll notice that the net link states, these guys right here, they're minimized, right? So if we come down here and we hit the up arrow, the OSPF database, the network, right? They're still, that's weird. Why is that showing up that way? Oh, I'm sorry. I made a mistake. I was reading that wrong. They're still here, but they're here for the connections to the ASA. This is the ASA's connection, and this is down to router 5. So we're still using we're still using the mode of broadcast on those interfaces, but the connections down to the V edges have gone away because we're no longer using the type 2 LSA. So it cleans up the OSPF database, and it makes the OSPF database not work as hard. So just keep those things in mind. Okay, so the next one I'm going to show you is going to be authentication. So type 1 authentication or clear text. So on the VEdge, so we'll do this on here real quick. And what I'm going to do is I'm going to show you how to do VEdge 1. I'm going to show you guys how to do, I'll do type 1 on both first, and then I'll flip it over to type 2 on both. So you guys can see how it works on both, because I want you to see the CLI and through the config of, through the template. So in this case here, we're going to go look at interface G0/0. So our adjacency towards these guys are going to go down. So I'm going to type in IP OSPF, and then the command is going to be authentication. And I'm going to hit the enter key, and then I'm going to come back here, dash key, and it's going to be Cisco 123, for example. Okay, so that's going to enable authentication at the interface level. If we do show IP OSPF interface G0/0, it's going to say simple password authentication is enabled. Okay, so now I'm going to do the same thing. So do show run interface gig0/0. Our OSPF adjacency will eventually go down. So I'm going to go grab these couple lines. Interface G0/1. I'm going to go ahead and paste those commands in there. I'm going to go back to VEdge 1. And underneath this interface, I'm going to specify authentication, and it's going to be type, and it's going to be simple. And I'm going to come back here to be the authentication key will be Cisco 123. So if we do a quick show config, fairly simple configuration, right? I'm going to go ahead and I'm going to commit that config. And on switch 16, we can see that the adjacency went down, and then as soon as that commit pushes, we should be able to get the authentication back up, and we're in good shape. So that's how you do it with the CLI. Really simple, right? But we can see the connection going to vEdge2 is down now. So to fix that, we're going to go click on vManage, go back to templates. Underneath the dual site, for feature template, I'm going to go to here, OSPF template. I'm going to edit that. I'm going to go down to area, and I'm going to edit this underneath interface, and I'm going to expand advanced options. I'm going to come down here to authentication type. I'm going to say, in this case here, we'll say device specific, and the authentication key for this guy was going to be like that. So that's going to be device specific, so we're going to have to populate that information. So we're good to go there. Alright, so we've got those changes in place. So let's just recap real quick what we're doing. We're enabling authentication of the simple type, and we're going to be setting the key of Cisco 123. So I'm going to save changes again, and then what I'm going to go do is update and give that a couple seconds to do its thing. I'm going to come in here, I'm going to edit device template, and down here at the bottom, we're going to see the authentication type. We're going to choose simple, and for the key, we're going to type in Cisco 123. Okay, that's the key. It's clear text authentication. So in other words, if you were to Wireshark capture this, you would see the authentication mechanism going back and forth because it's clear text. That's why it's type 1 authentication. Obviously, not very strong. So don't use type 1 authentication. But I'm showing it to you only for the fact that if you get tested on it, you know, and they say, what's the difference between type 1 and type 2 or clear text and whatever, now you're going to know. So I'm going to click on update and then click on next. I'll grab the device real quick and we'll wait for the config diff to pop up. Alright, the config diff shows us that we're going to be doing the exact same thing we did on the vEdge 1, authentication type simple, authentication key Cisco 123. I'm going to go ahead and configure devices. We'll go ahead and push that config down, and I'll bring you guys back in when we're good to go. Okay, so we should be just about there. I wanted it to be live for you when it came up, so you should have caught that it's good to go. There we have the success, so we know we're squared away, that we have authentication type of Cisco going. We're good to go there. And that's simple type, that's clear text, type 1 authentication, which is clear text for Cisco. Alright, so the next type of authentication we're going to take a look at is going to be MD5. So again, we're going to start on the Cisco side, and then we'll configure this to be on the vEdge side, so you can see what that looks like. I'm going to change the mode, and I'm not going to take it off and put it back on. So we're going to do that real quick. So we're going to do interface gig 0/0 first and type in IP OSPF authentication. Authentication here is a little bit different. Authentication, we're going to say message digest, and then underneath here we back up a couple, and then we say we remove authentication completely, and then we type in message digest key. We give it a key ID, we'll say key 1, and then it's going to use the MD5 algorithm, and then we're going to specify Cisco 123, and that's our configuration. So do show run interface gig 0/0. We can see, and we're going to actually remove this one here because it's got both of them here. So we're going to remove this guy, which is clear text. We're going to remove him because we're no longer using, this is the command you would use to implement just clear text authentication. When you want to use MD5, you add this command in. So there we have that. So do show IP OSPF interface G0/0. We're going to see now we're using cryptographic authentication enabled. The youngest key is ID 1. So they both have to use key ID 1. So if, for example, where that comes into play with the different keys is if you're using a key chain and you wanted to use rotation to swap between keys to keep your authentication strong. Never worked with it in production, but it is something I've tested out. It's not very difficult to understand, but you'd have to create a key chain first and then attach the key chain to the key configuration underneath the interface and then apply that. Not that difficult, but it's something you would probably want to play with. But right now, we're just going to keep it pretty simple with MD5 authentication. So the next thing I'm going to do is on the vEdge 1 side, I'm going to go underneath here. I'm going to type in no authentication type simple and no authentication key authentication key Cisco 123. I wish they would have done a little bit something different with the syntax, but it is what it is. I'm going to go ahead and commit that real quick, and I'm going to type in authentication is going to be message digest, and then message digest key ID 1, and then MD5, and then the password, which will be Cisco 123. But then you also have to do authentication type, and it's going to be message digest. And message digest. Well, I guess you could type it all in one command from the looks of it. I don't think I've ever done that. So let's do a show config, make sure. Yep, and then we're going to commit that config, and that should bring our connection to switch 16 back up. There it goes. So we're good to go. That's how you would do message digest authentication there. So now let's go do the same thing on gig 0/1. So I'm going to go to interface gig 0/1, and I'm going to do show run interface gig 0/1. I'm going to go ahead and get rid of the config real quick, and there we have it. And I'm going to go ahead and basically copy and paste these 2 lines of config in, like so. And then I'm going to go back to here. I'm going to go template. I'm going to go dual site only. I'm going to edit this, I'm sorry, feature template, not device template. Grab a feature template. I'm going to grab the OSPF one because it does tell you the type right there. I'm going to edit this under area, and then edit, hit the little pencil underneath the interface, and under advanced options, we're going to keep the type here, but we're going to remove the key. We're going to set this to default, and then underneath here, the key ID, we're going to set that to device specific, message digest key, and I'm going to put at the end here ID, key ID, and then I'm going to put underneath here device specific, because then the device says OSPF MD5. We'll go with that, because then that makes it easier to understand. I'm going to click on Save Changes. So just to recap, authentication type will be this will be MD5, right? Then the key ID, we need to specify that, which will be key ID 1, and then the actual message, the OSPF MD5, it's key. So let me stretch this out just a little bit so we have a little more room to work with. Come underneath here, and then underneath the key, MD5, we'll type in key, not the key. So this will make it a little easier to understand. MD5 key versus the key ID. Or should I use, yeah, that'll work. I'll know what to type in. And then we're going to go ahead and say Save Changes. Save Changes again. Click on Update. And then after it goes ahead to this point, we're going to go ahead and edit device template. We'll switch this to be message digest. The key ID will be 1, and the message itself, the key will be Cisco 123. And you can see that it stars it all out. Click on Update, Next, and then Configure Devices. We'll do a quick push on that, and we'll bring you guys back here in just a second. Alright, so I wanted to bring you guys back in before it went live, and there you go. Now we're good to go. Sometimes the template shows that it's not ready, but in reality it really is. So there we have it. So if we do show IP OSPF interface G0/1, we can see that we're using cryptographic authentication and key ID of 1. So that, ladies and gentlemen, is how you change the network type, and you specify clear text type 1 and MD5 or type 2 or cryptographic authentication for OSPF on both the iOS and the vEdges. Pretty straightforward stuff. So if you have any comments or questions, please leave me a comment in the comment section below. Please like, share, and subscribe, and I'll catch all of you guys in the next video.